So part 2, we need to find the intervals of increase and decrease. So I know that to find the intervals of increase and decrease, we need to find the derivative of the original function. And using the quotient rule, I found that the derivative of fx is x squared minus 2x over x minus 1 squared. Now to find the horizontal tangent, or the maximum and minimum values of x, I need to set f dash x to equal to 0. And when I do this, I found that x equals 0 and x equals 2. But I also know that we found in the vertical asymptote that x equals 1. So I put the values of x equals 1, x equals 2, and x equals 0, x equals 1, and x equals 2 into the table that gives me the intervals. So my intervals were negative infinity 0 to 0, 0 to 1, 1 to 2, and 2 to positive infinity. And when I substituted my test values into the functions of x squared, x minus 1, and f dash x, I got that fx increases on negative infinity to 0 and 2 to positive infinity. Fx decreases on 0 to 1 and 1 to 2. And I know that the local maximum is at the x value of 0. And when x equals 0, I plug in x equals 0 into the original function and found that y also equals 0. So the local max is 0, 0. For the local min, I know that the local min is when x equals 2. So when I substituted 2 into the original function, I got that the local minimum is 2, 4. Now to find the concavity, or the points of inflection, I would have to find the second derivative of the original function, or just the derivative of f dash x. And again, when I use the quotient rule, I found that the second derivative of the function is equal to x multiplied by x minus 3 over x minus 1 squared. So again, I use the values of x equals 0 and x equals 3, along with x equals 1 for the denominator. And I use those values as my intervals for the chart. So my intervals were x is less than 0, x is equal to 0, x is between 0 and 1, x is equal to 1, x is less than 1 but greater than 1 but less than 3, x is 3, and x is greater than 3. And when I substituted my test values from those intervals into the second derivative, I found that fx concaves up when x is less than 0 and x is greater than 3. Fx concaves down when x is between 0 and 1 and x is between 1 and 3. And the point of inflection is at x equals 3 and at x equals 0. So based on this information, I drew my graph. So I started off by drawing my vertical asymptote, which is at x equals 1. And then I drew my slant asymptote, which is at y equals x plus 1. So you can see that the two asymptotes intersect. Next, I plotted my x and y intercept, which was the origin, 0, 0. And I know my local maximum was 2, 4, so I plotted that in. Next, I used my table of increasing and decreasing intervals to determine that this is what the graph would look like. The green highlighter shows the highlighted part the green highlighted part shows the intervals of increase, and the part that is highlighted in orange shows the parts that are decreasing. And this is also confirmed with the table that I made for the concavity and the points of inflection. So this is the final graph of fx equals x squared over x minus 1. Thanks for watching.